All right, what's up, virtual learning AP statistics students? This is Mr. Bachman, and this is the lesson that I plan to teach quarter 4, week 2, day 2. So this would be the lesson that I teach my in-person students on Wednesday or Thursday of week 2. We're still on Unit 6. Today's topic is Type 1 and Type 2 errors. All right. So what we're going to do today is a question of the day. We're going to fill out a couple documents. One, they're both in Schoology. One is the Inference for Proportions Review Grid, and then one is a resource document on Type 1 and Type 2 errors. And then I'm going to run through an example of some Type 1 and Type 2 errors for the CHU section. And then I'll set up your asynchronous work for the rest of the week. All right. So let's start with the question of the day. I'll read it out loud, give you a minute here to pause, work through the problem. This will be a 4-step z-test for P problem, and then I'll run through the solution with you. All right, here we go. A popular commercial claims that 9 out of 10 doctors recommend aspirin for their patients with headaches. To test this claim, a random sample of 100 doctors is obtained. Of these 100 doctors, 82 indicate that they recommend aspirin. Test the true proportion is something other than 9 out of 10. Use alpha equals 0.05, and then do use the 4-step process on this one. So take a second, pause, work through the problem, go ahead and submit that to Schoology, and then you could unpause and watch the rest of the video for the solution. All right. Okay, welcome back. All right, so what we're going to do is, so what I like to do when I start these problems is notate all of the information that I have. So I know that my n value is 100, so I'm going to notate that, n equals 100. And let me find the right pen size here. Let's go with this one. And then my p hat value is 82 out of 100. And that obviously is 0.82 is my sample proportion. It tells us to use an alpha value of 0.05. So that kind of keeping track of the information provided in the problem. And then I can move on to step 1. So step 1, remember, we're going to do the procedure, the parameter, and write our hypotheses. So I'm going to start off, so this is a z-test for P. So we're doing a hypothesis test for a proportion. So I will conduct a z-test for P, where P is and then I want to name my parameter. So what this is going to be is the true proportion of doctors that recommend aspirin for their patients with headaches. So where P is the true proportion of doctors who recommend aspirin for headaches. All right. So that is almost all of step 1. The last part is to write my hypotheses. So my hypotheses always come in pairs, null and an alternative. So the null hypothesis, so I want to make a hypothesis for P. And I'm going to use now the commercial as kind of my claim. I'm going to assume that the commercial is true. And then I'm hoping to have evidence to support my alternative, which would then state that that claim is false. So my null hypothesis, as the commercial said, is that P is going to equal 0.9. So 9 out of 10 doctors recommend aspirin for headaches. And what I'm trying to do is, so if I look through the problem here, it says, is something other than 9 out of 10. So this one, we haven't really seen one of these before, but this is what we call a two-tailed test. So it's going to be a not equal to alternate hypothesis. So we're not really trying to show that, more than 90% of doctors recommend aspirin or less than 90%. We're just trying to show that this claim from the commercial is false. It's not 9 out of 10. Okay, and I'll talk about what to do. Really, this will come back up in step 3 when we have to consider this not equal to alternate. Okay, step 2 is our conditions. So I did have a random sample. It is stated here in the problem. So random is a check. 10% rule is the next one we need to consider. So n equals 100 is less than 10% of the doctor population size. Okay, so that's the next kind of condition. And then I want to go and do my n times p. So I take 100 times 0.9. And again, that p comes from the null hypothesis. So I'm assuming that the commercial claim is true. So this is 90, which is greater than 10. That is another check. And then n times 1 minus p. So this is 100 times 1 minus 0.9. So that ends up being 0.1. So this is actually 10, right? It's equal to 10. That is allowed. It's greater than or equal to. So we're kind of right on the border there, but we are able to meet the conditions here. So we'll say conditions met. All right. Step 3 is now where I do my test statistic and my p-value. So I'm going to go ahead and draw my distribution. So remember, I need to find my mean and standard deviation of my sampling distribution. So mu sub p hat, remember that's just always equal to p, which is my null hypothesis, so 0.9. And then I'm also going to do my standard deviation. So it's 0.9, square root of 0.9 times 1 minus 0.9 over 100. And that standard error is 0.03. So if I draw in my distribution, okay, it will be normal since those conditions were met. This is my p hat axis and my z axis. It's going to be centered at 0.9. And I'm going to be counting by 0.03, which was that standard deviation. So 0.93, 0.96, 0.99, going down, 0.87, 0.84, and 0.81. And then I'll put in those corresponding z-scores. Okay, so now what I want to do is now I want to place where that 82 out of 100 is, my p hat value. So I want to put that number on my distribution. So remember, that comes from here. This is p hat. I want to know where does that fit on my distribution. So p hat is going to be right about here, almost to 3 standard deviations below the mean. And then I'm going to shade to the left here. So I'm going to shade that left tail. Now remember, I said that this is a two-tailed test because we had a not equal to alternate hypothesis. So again, this is called a two-tailed test. Sometimes it's called a two-sided test. Those are synonymous terms. So I have the left tail shaded. So then what I have to do is I have to figure out what the z-score is for this value. So I'm going to go ahead and find my test statistic here. So it's 0.82 minus 0.9 over 0.03. And that has a z-score of negative 2.667. So again, now since it's a two-tailed test, I'm also going to shade the basically the tail that's symmetric on this distribution. So what I'm going to do is I'm going to figure out where a z-score of positive 2.67 is, and that's going to be about here. And then I'm going to shade to the right. So again, that matches up with a z-score of positive 0.2667. And again, over here is the negative 2.667. So again, I'm shading the two sides, the two tails, because this is a not equal to alternate hypothesis. Okay, the next thing I'm going to do then is calculate my p-value. right? That's the whole kind of purpose of calculating the, or doing the hypothesis test. So what I'm going to do is I'm going to first start by just finding my left tail. So I'm going to do my normal CDF. My lower bound is -1 times 10 to the 99th. Oops. So 10 to the 99th. My upper bound is going to be that 0.82. My mean, u sub p hat, is 0.9. And my standard deviation is 0.03. All right, so I'm going to put all of that into normal CDF on my calculator. And what I'm going to get, I'm going to just intentionally leave a little space here. I'm going to get 0.00383. So that was normal CDF. Now that's just the area of this left tail over here. So that's this region here. But now I also want this region here. Both of those two areas together are going to form that p-value. But now because of symmetry, all I need to do is multiply what I got from normal CDF by 2. And if I do that, I'm going to get 0.00766. So still a pretty small p-value. All right, so now what I'm going to do is wrap this up in step 4. See, I don't save myself a ton of room. It's going to be a little smaller here, but all right, so we're going to do step 4. So now step 4, I'm going to compare that p-value I just calculated, 0.00766, and I'm going to compare that to my alpha value of 0.05. So I can see it's quite a bit smaller. So the conclusion that I'm going to reach is reject the null. So I'm going to reject the null. So what that's going to do is give me, so there is significant evidence. Remember, if you reject the null, there's significant evidence for the alternative. So there's significant evidence to conclude that, oopsies, that the true proportion of doctors who recommend aspirin for headaches is not 0.9, right? So I am able to reject that null, giving me evidence against what the commercial claims. So it is something other than 0.9. All right. Okay, so then that is the question of the day. So check your work on that and submit that to Schoology. All right, so we're going to move on to our next thing. So this is a document that is available in Schoology. It might also be something you just want to print out if you have access to a printer. I think this might be handy. So I did kind of have this available before spring break for our confidence intervals. So what I have here is a grid. We had type, purpose, conditions, critical value, interval formula, and calculator trick. So I'm going to go and do kind of the same thing for this z-test for p that we have here. So I'm going to fill this out. You can kind of do this along with me. So we have purpose, conditions, test statistic, how to calculate the p-value, and then we have a calculator trick. So I'm going to go ahead and just kind of go through each of these. And then down here is the 2 sample z-test for p1 minus p2. We're going to save that for another day. We're just going to do this first row. Okay, so the purpose of a z-test for p is to test a hypothesized population proportion. So we're making a hypothesis about a population proportion. And that's what we're doing our significance test on. All right, so that is the purpose. Conditions. So we're pretty familiar with these at this point. We need a random sample. Okay, I'm just going to write 10% rule. And remember what that means is that the sample can be no more than 10% of the population size. So that 10% rule needs to be met. N times P needs to be greater than or equal to 10. And N times 1 minus P greater than or equal to 10. So those are those conditions. Next up is my test statistic. So this is my z-score. So z equals, and what it's going to be is it's going to be your p hat value minus the mean of your sampling distribution. Well, the mean of our sampling distribution is also just simply the hypothesized p. So it's basically the p from your null hypothesis. Sometimes you'll see it with like a little 0 here in the textbook. That's again just saying that's the proportion from the null. And then we got to divide by that standard error, and I'm just going to use that whole formula. Remember, and that's p times 1 minus p over n square rooted. So that is that test statistic. Now, how to calculate the p-value? Well, that's just normal CDF. We've been using that quite a bit. So you need lower bound, upper bound, mean, and standard deviation. And then the calculator trick here is 1 prop z test. All right, I will show you that. So let me just go over to my calculator here. Sorry, I gotta load it up. So this is gonna be, I'll just use the one that's on the calculator, or sorry, on the iPads. So bear with me here. All right. So to access 1 prop z test, you hit the stat button, you go over to tests, you go down to 1 prop z test, option number 5 on this calculator, hit enter. Where it says p with a subscript of 0, p null, that's what you put in as your null, the hypothesized, or sorry, the proportion from your null hypothesis. X and n, this is the 82 is x, and the n is 100. This gives me a chance to put in what my alternative hypothesis is. So this was a not equal to on this question of the day. And then I'm going to go down to calculate, hit enter, and then boom, you can see all of this important stuff. We can see the z-score is there. We can see the p-value. It gives it to us as p. I want you to write it down as p-value though, and notice it's already doubled for you. P-hat is just the sample proportion, and then it gives you n. So lots of good information. If you go back to that same 1 prop z test, you'll notice that it also gives you another option as draw. So if I go over to draw and hit enter, it'll give me that picture, and you'll see that it has a little bit of shading on each of these 2 tails. This screen also does give you the z and the p-value as well. So pretty handy. When you do step 3, really you just need the z-score and the p-value. I always draw the picture just because I think it's makes it a little more intuitive. But really you just need the test statistic and the p-value. You get both of those right from this calculator function. So this definitely is a handy tool to have. All right. Okay, and again, we'll leave the second row for another day. All right, the next one I'm going to look at is this another resource document. This is also in Schoology. You can either work through it in Notability, or you can print it out and write on it. So again, this is all about type 1 and type 2 errors in hypothesis tests. Remember, significance tests and hypothesis tests are synonymous. So this is what the document looks like. I'll read through it. The context should be familiar. We've done this context a couple times already. All right, but let me read through this first part. So tests of significance assess the strength of evidence against the null hypothesis. Based on the strength of the evidence, we reject, which is a positive test, or fail to reject, which is a negative test so either reject or fail to reject a claim about a parameter, right? That's the null. Since it's possible to observe extreme statistic values in a given sample, it is possible we may mistakenly reject a null hypothesis that was actually true. Further, it is possible we may fail to reject a null hypothesis that is actually false. So hypothesis tests, you can make errors. We do have a couple different errors that we're going to go through here. So basically, anytime you run a test, there are going to be kind of 4 different possible outcomes. 2 of those outcomes are based on, or kind of 2 of the things that will be true is whether we're rejecting the null or failing to reject the null. Then also we can think about, well, the null may actually be true or it may actually be false. So this will kind of allow us to talk about and kind of evaluate the errors that can be made here. Okay, so if I think about these errors, sorry, give me a second. So let's think about, first of all, let's think about the good outcome. So what do we want to do in a significance test? Well, let's think about, first of all, rejecting. So if we reject the null, that's going to be called a positive test, right? We want to reject the null. We want to have evidence for the alternate. So that's going to be a positive test if we find that evidence. So if we are rejecting the null, we want to reject a null that is false. So rejecting a false null is a good outcome, and that's this outcome right here. So I'm going to write good right here. So rejecting a false null is a good outcome. So then the other one where we're rejecting a true null, well, that's a mistake. That's an error, and that's what we call a type 1 error or a false positive test. Right? You may have heard that terminology before. So a type 1 error is a false positive. It's a positive test, right? But it has a false outcome. So those are kind of, we have a type 1 error when you're rejecting a true null and a good outcome when you're rejecting a false null. All right, so let's go to the next one. So now what if the conclusion of your test was to fail to reject the null? So you can fail to reject the null. The null could actually be true or it could be false. So let's think about what's the good outcome here. So if I'm failing to reject the null, I want to fail to reject the null if the null is true, right? So this is the good outcome, all right? Which then failing to reject a false null, right? That's a bad outcome, and that's what we call a type 2 error. Type 2, and I'm using Roman numerals. That's just kind of the convention for these 2 types of errors. And a type 2 error is what's called a false negative, so a negative test that is actually false. Okay, so all right, so then a type 1 error. So a type 1 error is when we reject a true null, and in parentheses I'm going to write false positive. So again, that's a type 1 error, and I do want you to remember these, so kind of might have to memorize which is which. And then type 2 error is to fail to reject a false null, and then this is what we call a false negative test. Okay, so now what we're going to do is look at a couple of these and see, we're going to look at an example and then try to kind of evaluate type 1 error and a type 2 error. All right, like I said, we are familiar with this context. We've had it a couple times. Local prison is trying a new program to reduce crimes committed by recently released prisoners. Nationally, the proportion of prisoners that return to jail in less than 1 year is 0.61. The local prison takes a random sample of 42 released prisoners and found that 16 returned to prison within a year. Based on the local prison sample, they claim that their program is working. You have been hired to test whether or not the prison should continue to fund their program. So what are the null and alternative hypotheses you would test? So again, we've done this we've used this example a couple times already. So we want a null and an alternative. So our null is that P is going to equal that national proportion. So that local proportion is going to be the same as that national proportion. So P is equal to 0.61. I'm trying to show that that program works so that P is less than 0.61. So I want that local rate to be less than the national rate. Okay. What we're going to do is we're going to define the type 1 and type 2 errors in the context of the problem, and then we're going to look at the implications or the consequences of each type of error. Okay, so we are, so if we look at the type 1 error, the type 1 error in this case is if we were, so let's think about if the null was actually, so if we're making a type 1 error, the null is true. So that means that the release rate for the local prison is the same, or the recommit rate for the local prison is the same as the national proportion. So, so really this program is not working if the null is true. Now, if we're making a type 1 error, we're rejecting that true null. So really, if we're making a type 1 error, we are going to be claiming that the program is working, that the program works when it really doesn't. All right, so again, claiming that the program works when it really doesn't. So you are, your null is false, right? So that tells us the program doesn't work, but we're rejecting that. So we're saying really that the program does work when it really does not, right? So that's would be a pretty significant error if you were doing this evaluation. All right, a type 2 error now is when you fail to reject a false null. So if the null is false, that means that the program really is working, right? So if that null is false, that means we have evidence for the alternative. That means that the proportion is actually less than 0.61 for the local prison. So the program is working, but if you're failing to reject, you're not saying it has evidence that it's working. So you're basically saying the program is not working when it really is. So we'll say here is that type 1 error would be claiming the program is not working when it really is. So when it really does work. All right, so those are kind of how we would define each of those two errors in the context of the problem. All right, so now if we think about the implications or the consequences of each type of error. So if we're thinking about a type 1 error, if we're claiming the program works when it really doesn't, right, then we would be supporting this program, we'd be funding this program, we'd be dumping resources, money into the program, when it's really ineffective. So what we would say for the implication or the consequence of a type 1 error is we would say it is wasted money and resources on an ineffective program. Right, so if you're running this prison, you certainly don't want it. You could be using your resources in other ways on other programs. So this would certainly be an error. Type 2, so if we're claiming the program is not working when it really is, So that's also a pretty significant error. So in this case, what you would be doing is you'd be losing that opportunity to both rehabilitate criminals and also to decrease crime. So what we would say here is that we would have a lost opportunity, right? Because if we're basically claiming the program's not working when it really does work, we're going to pull funding from the program, probably cancel it altogether. But it's a lost, sorry, let me spell that correctly, lost opportunity to rehab prisoners and reduce crime. All right, so I would say in this case a type 2 error would probably be worse. Type 1, you're wasting money, wasting time. But that type 2, that lost opportunity to rehab people and reduce crime, I think that would be a more significant error to make. So as you're going through these types of type 1 and type 2 problems, when you're looking at a context, sometimes a type 1 error might be worse, sometimes a type 2 error may be worse. But you want to kind of do that, evaluation to kind of see what each type of error, what the consequences would be. All right, and then how can we reduce the likelihood of a type 1 error? So if we think about a type 1 error is when we are rejecting the null. So if we think about what tells us when to reject the null, it's when we compare our p-value to alpha. So basically, if we use a larger alpha value, so if we increase that alpha value, we're going to reject less, right? So that's going to reduce. So if we reject less, we're going to make a type 1 error less, right? So we're going to reduce that likelihood. How can we reduce the likelihood of a type 1 error? Increase alpha. Okay, so there's some information on a type 1 and type 2 error. So what I'm going to have you do now is work on this next problem. I'll read it to you, and then I'll give you a moment to pause the video and work through it. So it says, suppose you work at a security checkpoint at the airport. Travelers are screened to see if they have any weapons or other dangerous materials. So you are essentially running a significance test where, now the null and alternative here don't have any numbers, so this isn't, technically what we'd be doing, but we can kind of think about it in terms of what's going on here. So the null hypothesis is that the traveler does not have any dangerous materials, and the alternative is that the traveler does have dangerous materials. So number one, you're going to write about the two conclusions possible in context for the significance test, and then what is a consequence of each conclusion. All right, so go ahead, pause the video, do a little bit of writing. So what would be the conclusion of both a type 1 and type 2 error, and then what would be a consequence of each. Okay, so go ahead, pause, and do your writing. All right, welcome back, good work. All right, so type 1 error in this case. So remember, if we go back and look at a type 1 error is when we reject a true null hypothesis. So if we think about if the null is true, that would mean that the traveler does not have any dangerous weapons, but the test is going to reject that. So the test is going to say the traveler does have dangerous materials when they really don't. So that would be a type 1 error, is you would be claiming that a traveler has dangerous materials when they really do not. So if we think about a consequence of a type 1 error in this case, basically it would slow down, so it would slow down the screening process. You'd be conducting further screening measures on somebody who doesn't in fact have any dangerous materials on them. Probably also going to maybe make them mad, make them angry, but that would be a type 1 error. A type 2 error in this case, so if we go back and look at it, type 2 is when we fail to reject a false null. So if the null is false in this case, that means the alternative will have evidence for the alternative. The alternative is the traveler does have dangerous materials. So if we're failing to reject that false null, basically what we're doing is we're not kind of catching the traveler that does have dangerous materials. So that traveler is going to be able to get on a plane with those dangerous materials. So again, a type 2 error is that the traveler does have dangerous materials, but we don't have evidence for that. So we're going to kind of let them go through the screening point. So again, consequence of that conclusion, obviously then somebody would have dangerous materials on an airplane, which is what we're trying to avoid. So in that case, I would say probably that type 2 error would be a little bit worse. Okay, so that is that example of a type 1 and type 2 error. Okay, so we're just about to the end here. Asynchronous work is the same as, I had this exact same slide in the day 1 video. So this is the same problem set. Hopefully you've got a good start on that. You now, since I've gone through type 1 and type 2 errors, you now can do these 3 problems if you were waiting to do those. If you haven't watched these 2 videos yet, please do so for your asynchronous work this week. Okay, that's it. That's your lesson on type 1 and type 2 errors. Thanks for watching.